Welcome everybody to session 4 of Hack Summer. My name is Taggart, and tonight we are doing some programming in a way. We are doing some shell scripting, and so continuing our exploration of Linux and how we can use it in cool projects. We're going to automate some stuff by using not just the commands that we've already learned, but how to automate them, put them into scripts so that we can run them again and again. So, not a whole lot of prelude here. Let's jump right in. Welcome everybody. Hey GoPro, good to see you. All right. So, starting right off, let's talk a little bit about shell scripting. It's the penultimate session for Hack Summer, but in terms of the stuff that we've gone over so far, it is a little bit of a culmination, because it requires you to understand everything about the Linux operating system that we've done so far in order to write effective shell scripts. That's kind of a prerequisite for maximizing your capability with shell scripting. It really is great for automating common or complicated tasks, so you don't have to constantly, search your command history or constantly copy and paste commands again and again. Saving common or complex operations into a shell script that you can reuse or even schedule is a really, really handy trick of Linux system administrators. And I'll also say that, a lot of the folks here are security folks and they're not Linux systems administrators full time. That's totally understood. But even when you're setting up new tooling, or perhaps a command and control framework, or even a defensive framework, and you have to repeat the same operations again and again, it's really, really handy to have these things scripted so that you can predict the outcome and you can repeat your effort without too much reinvention of the wheel. And from a DevOps perspective, a lot of times these scripts can be fed right into tools like Vagrant or Terraform or Ansible, so that you can have your automations right there inside your shell script. Now, when we talk about shell, we're going to today focus on bash, and we'll talk a little bit about what bash is in a minute. But what we should know is that there's more than one shell available to us in Linux, and there are some alternatives that I think might be a better option when you're doing your shell scripting. And we'll also cover some of that. And so we'll start with the shebang, and we'll get into that in just a second. So let's quickly do like your first shell script, and then we'll move on from there. So here I am in my Linux VM. It's the same one that we've been using throughout the course. And I'm in my home directory. We have some stuff. There's some old stuff from old sessions there, like the Jeff Sum stuff that we used before. Which actually we might do with a script later. We'll see how it goes. But to create our first script, we're going to use Vim, because we've all learned how to use Vim from the last session. So we're going to use Vim, and we're going to Vim hw.sh, just for hello world, right? And this isn't going to be particularly complicated, but it's going to go over a couple of important items. So the first is we're in insert mode, of course. We begin the script with the shebang, which is the # or the hashtag if you're, a Zoomer, and the exclamation point, and then the path to the either shell or interpreter that should be used to process this script. Now, in this case, we're going to use bin bash, but there are others available. And we're just going to make this real simple to start. We're going to do echo hello world. And do try to use the double quotes where I use double quotes, because you're going to find out that the kind of quote matters in bash. So go ahead and do that. If you want to change up your color scheme or do anything else cool in Vim like we learned how to do last time, feel free to do that. But otherwise, go ahead and save and quit that with :x. Now, if we ls with a L, I didn't need the A. Let's just do a L. You'll see that, oh, that's wild. I didn't realize that LL was AL. Yeah, there we go. So you'll notice that hw.sh is just kind of a regular old file. It doesn't do anything special. And that's because we have yet to make it executable. To make a shell script executable, we have to set the execution bit on its permissions. And we went over chmod earlier in the course, but as a reminder, we have a couple of ways to set this up. If we want everybody to be able to execute this, we can really easily do chmod plus x to that shell script, and that'll go ahead and do it. If we want just us to be able to execute it, we can do u plus x for the user. If we want user and group, we can do ug plus x. But, and we of course can do it in the octal fashion as well, right? 755 or 7, that would be execute, right? 764 if we wanted to keep it the way it was, but add execute to us. Let's go ahead and do just plus x to keep it simple for right now. Chmod plus x and then hw.sh. When we ls again, we'll see, well, the color changed, but we'll also see that we added the execute bit to all three, the owner, the group, and to everybody else. With that, we can now execute this shell script. So you might think, oh, how do we execute it? For every other command that we have on the command prompt, we just type in the name of the command. So you might think, okay, cool, we'll just do hw.sh. But it tells us that the command is not found when we do it that way. And the reason why is because of the way that our shell looks for commands to run. By the way, this .sh, this is not necessary to create a shell script. We could have made the file without the .sh extension, and the file would work the same way. The extension is not how the shell knows that it's a shell script. It's the execute bit and the shebang inside the file. So it would work the same way even without the .sh. The .sh is just for us looking at it to know that it's a shell script. So why is command not found? Because of the way that your shell looks for commands to run. And that's your path. We're getting ahead of ourselves, so I'll save the path thing. But in order for us to actually run this shell script right now, we have to say kind of explicitly .hw or ./, right? To say we're looking at this file in this current folder, hw.sh. And because then it's not looking everywhere for a command called hw.sh, it's just looking in this folder, it runs correctly. All right. So quick history on the Bourne Again shell. The Bourne Again shell is part of GNU, and we talked about GNU a little bit at the very beginning of the course, that the GNU tools are an important part of the user space that Linux has now. And it's been around since 1989. So fairly long in the tooth, this shell. And despite that, it is still the default shell on most Linux distributions. And a lot of that is longevity. There have been updates to it. There also have been some vulnerabilities in it. But it is tried and true. And a lot of the scripts that are written, even to set up Linux distributions, especially in the user space, are written in Bash. And because of its prevalence, it is kind of the lingua franca of Linux shell scripting. It's not the easiest syntax in the world. I have learned I don't know how many programming languages at this point, and I will, to be honest with you, I will try not to write a Bash script if I can avoid it, but a lot of times I can't. So I want to be upfront with you that it is a little bit tricky if you're not used to the syntax. It takes some practice to get used to. It has a lot of weird gotchas, and we're going to go over those today. But let's start with some of the basic syntax. And I'm going to leave this cheat sheet up. And of course, the slides are added to the Git repo. So after the session, you're going to be able to take a look at these as well. But some basics we're going to start with would be variables, conditionals, loops, and functions. And these I'm going through because these are the four fundamental structures of programming, at least the four fundamental structures of programming in a imperative programming language, right? Not a functional programming language. So we're going to start with creating some variables and using variables, and then we'll go to conditionals and then do some loops and functions. Let's go ahead and write with some variables here. Now, variables we can use very, very easily from the script we already have. Let's start using one. Let's vim that thing. All right, so we're back in our script, and we're going to modify it to use a variable. And we'll call the variable name, and we'll say, in this case, you can set it to whatever your name is, right? And go ahead and change the hello world to hello $name. Go ahead and save that out. And now when we run hw.sh, things work as expected, but it's doing so using the name variable. Now, a few things here that I really want you to pay attention to. The lack of space here really matters. If we try it, let's go ahead and try it with a space after the equal sign. Right? So the way that Bash works is that it is crazy white space sensitive, even more so than Python. So I want you to be aware of that whenever there's an equal sign like this, those spaces really, really matter. There are going to be other places that you're going to see spaces matter, but that one's a huge one. There we go. A little bit of music going. All right. So we have a variable going, and we have this variable getting filled inside of our quoted phrase. Now, I want you to try what happens if we replace the the double quotes with single quotes. Doesn't work. So these are already two gotchas with Bash that I want to call out right at the front, because double quotes allow what is called variable expansion inside of Bash. With single quotes, it just reads it literally. But with double quotes, Bash knows to look for a variable called name or some other thing that we're trying to substitute with that $, and put it inside the quotes in that placeholder's place. And you can even see that Vim is helping us out here with our syntax detection, that once we have it inside double quotes, right, it's calling out, or it's offsetting in color, the name variable separately from the rest of the string. As a reminder, don't forget to shout any questions into the chat if you have them, because I want to make sure that everybody's questions get answered. Bash is not a simple topic, so I want to make sure everybody's questions get answered. And in case you don't have any questions now, but you might later, don't forget to join our Discord. All right, let's save this out. Let's go check out the next thing. So conditionals. If, and then we have a conditional that's a little bit interesting. We can talk about some of the conditional statements here. But then we do a thing. Right? So this syntax looks very, very strange here, and it's going to look less strange when we start typing it out, but these semicolons you see here are only used when we do one-liners, right? If we were to do this on the command line. That's why I wrote it this way here. But when we write these inside of a shell script, line breaks help us out a little bit. We actually usually use this for semicolon, but you don't technically need it because you can line break the then. But let's go ahead and try this out. And I'll hopefully remember how to do this the right way. So we'll try with this with a conditional. Right? We can say if name, and it should be EQ. right? Pretty sure that's correct. Oh no, it's double equals, I think. Or no, it's a single equals. That's very confusing. I got my PowerShell and my bash mixed up. So notice that the space makes it a comparator. And also notice the spaces between the beginning and end of the conditional statement here. Also, I'm pretty sure that you need to quote the variable here. It's crazy. Like, you actually do need to have matching quotes. So we'll say if name equals Taggart, then we'll say echo hello name. B. And of course we can also do, we could do an else. Very, very similarly, right? So we can put an else at the right after the if and say echo hello you. And then B is, notice it's just the reverse of if. It's a little clever, I guess, but it is the way that bash indicates that the conditional statement is over. All right, let's save that out. So it says hello Taggart because my conditional statement worked, but if I added like a G to this, right? Now it says hello you because the conditional doesn't match. So again, let's take a moment to really focus in on this. So to do a string comparison like this, we're doing a quote around the variable name. We're doing quotes around the string that we're testing. And here we're using a single equal sign surrounded by spaces as a comparison, rather than the single equal sign up here without spaces, which is a variable value assignment. So as you can see already, a little bit tricky to make all this work, but it allows us to work with the text on the shell in a really, really interesting way. Now, yes, I can repeat the last line, control byte. So let's go through this again. Regarding bash comparisons. Yep, for sure. So when we're doing a basic string comparison like this, what we're doing is we're quoting the variable and we're quoting the string. So those quotes have to match. And also we're using this single equal sign surrounded by spaces here to create a string comparison between these two things. If we didn't have those spaces, the syntax would be off. The spaces here also between the expression and the brackets themselves that set off the conditional have to be there. If there were not a space here, then the syntax would fail. So all of this exactly as written really matters. Now this is a little bit goofy because of course I don't have to do this comparison if I'm declaring the variable. But one of the things we're often going to do with our shell scripts is feed it in input from the command line. That's the whole point, right? We remember back to that Unix philosophy where we build simple tools that do their job well, we build tools to work together, and we use text as the mutual interface between those tools. So if that's true and we want to build with that philosophy in mind, we have to build our scripts to accept input from the command line or from the result of other scripts. So to do that, we have kind of pre-named variables. Let's clear out all of this, or we can comment this out as well. So to comment it out, you just put a £sign or hashtag at the very beginning of the line. And let's just leave all that out, right? And we're going to just do very simply echo $1. and go ahead and save that out. Now, if I run this again, nothing comes back. An empty space or an empty line comes back. Board against shell. Why is name in quotes? Because Taggart is in quotes. The quotes have to match Born Again Shell. If I remove them from both sides, then we're good. But notice, so here, what we're doing now is we're echoing number 1. What is number 1? This is the first argument given to the shell. And because we didn't give it anything, nothing comes back. But if whatever I give it with number 1, it will echo out. Now, remember that, again, spaces matter. So because I'm only dealing with that first command line argument, this hello is disregarded entirely. But if I wanted to, I could say echo 2, 1, and now works like that. By the way, because of the way that the shell cares about text and really works with text primarily, notice that I didn't really need to quote the echo statement. Right? It took that exclamation point and worked with it anyway. I don't like doing it this way because I don't want to have any questions about what my string is going to do, which is why I use double quotes when I want variable expansion and single quotes when I don't want variable expansion. But you can absolutely, even if I do echo like just like this without quotes, that works fine. Because again, this command echo is designed to work with text. Now, if we wanted to do this, right, let's uncomment some of these lines, or all of them actually. And we'll say if the first variable is Taggart, then we'll say hello, or even not even hello, we'll say I know you. And otherwise we'll say I don't know you. So if I run it this time and I don't give it an argument, obviously it didn't equal my name. So it says I don't know you. But if I give it my name, then it works. So variables and conditionals, we've got 2 of 4 covered already. We're making good progress. Now, at the very end, I'm going to show you the Bible for bash comparisons. But even just Googling for bash comparisons is going to take you to some really good resources of all of the different comparisons you can do. The one you're seeing here is one I use very frequently, the -f, which is a check to see if a file exists. So if -f etc password, right? If etc password exists as a file, which it should, but if it does, then you cat out the password, right? That's kind of what the script would do. All right, now we've covered variables, we've covered conditionals. Very often, the reason we are writing a script is because we want to automate simple procedures, but repeat them for many, many different entries. And that's where loops come in. We have 2 kinds of loops inside of Bash, just like we have 2 kinds of loops inside of many kinds of programming languages. We have for loops, which we're going to focus on, and we have while loops. So again, you can see that Bash really is a full-out programming language. It's just designed to work inside the shell in a really interesting way. Let's go ahead and try a loop here. And one of the things that I'm going to also demonstrate with the loop here, let's go ahead and vim up that hw.sh. Let's go ahead and either comment these out or delete them if you want. I'm going to comment them out just so that they're there. But now I'm going to create a new variable called names. Names equals yeah. Star Wars mood tonight, I don't know what to tell you. Now you might think, wait, don't I need like brackets or parentheses or something or whatever? Nope. And this is actually a very common gotcha even when you're running scripts on the command line and the input doesn't seem to be what you expect it to be, or the output is not what you expect it to be, because spaces, as we just saw with using the $1 and $2, spaces separate values. And so this is a perfectly acceptable list inside of Bash. To prove that point, we'll do for n in names do echo, I don't know why that was tabbed in so freaking far, echo n, and then done, which is the ender for a loop. So check our syntax here. For, we create a little variable. It can be whatever variable name you want, but you know, I usually like to do the first letter of the group variable that I do. So for n in, and actually this is wrong, it should be n in $sign names, parentheses, do, echo n, I didn't need that, extra semicolon. Volrath, thank you so much for the follow. Echo n, and then we're done. So done closes off the for loop, just like the fee closed off the if statement. Let's try that out. Oh no! I did a stupid. There we go. I had to quote it, but the space still separated it out. So you can see that once this was quoted, again, those quotes really matter. Single quotes would have done fine too. But once I have that quoted out, it echoed each one on its own line. Now, why is that if I didn't do a line break? Because echo itself inserts a line break into, by default, into whatever you're putting into the standard out. So we get a line break with each of these. This can be very confusing for new Bash scripters. And it's confusing even to me when I forget how to do it. But spaces separate values, and when you are reading in input and you forget that spaces separate values, you can get some really interesting results because you've forgotten that, right? You might have more than arguments than you think you would, or things might not work as well as you would expect. Now, while loops are a little bit different in Bash. We haven't done any math here, but we're gonna try to do some at the moment. So let's comment these out. So we're gonna try, if I remember how to do this. We'll say count equals 10. And we'll say while, then making sure that I have my, while count is, oh, well, hang on a second. While count is greater than or equal to 0, do echo n, and then we have to do x equals, or count, sorry, not x. Wow, I am mixing variable names like crazy here. I am sorry. Well, count is greater than or equal to 0, echo count, and then count equals, and this gets a little bit interesting. We have to parenthesize this with a $sign because we have to do some work, some math. Count minus 1. And then, of course, done. And then once that's done, we'll echo liftoff. So before we run that, let's go through that very, very carefully. So we have a while loop where we initialize a variable called count to 10. Then we say while count is greater than or equal, again, we have those comparisons, greater than or equal to 0, do the following. We're going to echo count, and then we are going to subtract count. We subtract 1 from count by saying now count is equal to the result of this expression, which is count minus 1. The double parentheses are a little bit interesting. We're basically saying this internal parentheses is about doing mathematical expressions, right, rather than text expressions. That's part 1. And then the second part is we're doing a substitution of the operation into the result. If that wasn't clear, please let me know. I will go through it again. Oh, crap. What did I do wrong? Yeah. Extra $sign? Yes. Good call. Very good call. Thanks, Gromit. Is this needed? Yes, I'm pretty sure it is. Let's try it without it. So if we do count minus 1 without the parentheses, some bad stuff happens. So what we're saying is, out here, we're saying create this substitution. And then in here, we're saying perform this operation. That's why we do it that way. Yeah, I don't use while loops that often in Bash because I don't use while loops that often in programming because they're actually kind of messy. Relying on a condition is often very fragile to stop a loop, which is why I don't do it that often. If I have to do a loop through something, I will more likely than not do a for loop so that I know at least that I'll have a stopping point, because the maximum number of loops possible is however many things there are. Whereas with a condition, if there's some situation that would make the condition not ever be met, I might have an infinite loop. So I tend to not use while loops because they tend to be a little bit fragile. But this is how you do them in Bash. Okay, last piece then of the 4 fundamental structures would be functions. Just going to comment all this out. And then we'll go on to functions. And get a little bit more space going on here. And we'll go into functions. So functions don't work quite the way in our scripts, the way that you might think of functions if you've done other programming. So when you think about regular functions in other programming languages or real programming languages, they accept arguments, which you can do, but you can't necessarily define them in the function definition here. So what we're looking at here is that we define the function with the name of the function, right? And then parentheses. And then in brackets, or in curly braces rather, we'll put in whatever operations there are for the function. And then we call the function with x and then whatever arguments we give to it. But notice that within the function itself, we use again that $sign and then the numbered variables to indicate the numbered argument that we are providing when we call the function. It's not like we get to define the arguments or the parameters inside of the function definition here. So instead, let's try that. We'll make a function called greet. And we'll close that off with curlies. And then we will say echo hello 1. Again, just like we did before, and we're using double quotes, so there's variable expansion. And then we're going to say, for our function itself, we're going to say greet username if you want. And our function works. Now, interestingly, if I wanted to use a command line argument, I could do that with just like that. So on the outside of the function, the $1 refers to whatever is coming into the shell script in order for me to run it. Then inside the function, it's whatever gets fed in by when I call greet. So that $1 is a different meaning inside of this function. And I noticed that it was blank, right? Because I didn't give it anything. But once I give it a command line argument, it works fine. So I don't use functions that often in my shell scripts. They don't get that crazy that I need to. But it's a good structure to know. And of course, there is one situation that somebody probably has shown you that that uses the function definition. Which is, I'll paste it in here, but we won't call it. So a prank that people like to pull on new command line users is this right here. This is known as the fork bomb. And what are we looking at here? This is taking advantage of how weird Bash can get. What we are looking at is a function definition for a function called colon. And then inside of that function, what happens? The function calls itself. It then pipes whatever the result of that function is to itself, and then the ampersand backgrounds the task so that you can't see it happen, right? So that's the end of the function definition. The semicolon ends that function definition, and then the very end of the script, this one-liner, calls the colon function, which, and this is why it's called a fork bomb, because the function itself will fork many times, creating different instances of that process again and again and again and again, and eat up all of your memory. And you won't see it happen because the task is backgrounded. So don't do this on your machine because it'll shut you down. But it's taking advantage of how the bash function definition works. Okay, let's see where we are. Now, we've been spending a lot of time in bash, and that's really where most shell programming in Linux still lives, but there are other shells that are available to you. There is the C shell, which I don't use that often, but it's in there. There's Z shell, which is now default on new instances of Kali and on Mac OS. There's also my personal favorite, which is the Fish shell, and I should probably link that in there for anybody who's interested. Yeah, fishshell.com, pretty easy to find. Toss that in the chat. I like Fish because it has a lot of the modern niceties that Z Shell has, if not more, as well as really good highlighting and even clearer scripting. It really has a nice set of helpers for that. I'm also calling out sort of a special mention for the Conch shell. Conch is pretty wild, but if you want to check it out, I highly recommend it because it's Python powered. So imagine if Python itself were your shell. It works just like your regular shell, but then when you're ready to do Python stuff, you can just do it on the command line. It's really, really powerful in that way. Conch is cool. I don't use Conch that often, but I am really excited that the project exists because I think it's a really nice way of kind of splitting that difference between when you need more powerful scripting and when you want the ease of the command line. So all of these are scriptable, but because of Bash's universality, most shell scripts are written in Bash. And we've just spent some time learning the Bash syntax so that we can do that. We can enter our commands. We can create automated processes. That being said, I wanted to take a moment before going any further tonight for a little bit of a hot take. And I might get some pushback on this, and if I do, I totally understand. This is my own wisdom that I have earned through blood, sweat, and tears and being a system administrator for hundreds of different machines that I needed scripts running on, and different platforms that they needed to work all the same, which is write your shell scripts in Python. If we're talking about universality, Bash is good, but I think today, especially if we think about Mac OS as well as maybe even Windows, Python can be even more universal than Bash. And as much as I appreciate the Unix philosophy for using text as its universal interface, every once in a while you need better data structures than just text. And to take advantage of that, you need something that's a little bit more robust than just Bash. That's where Python comes in. You can execute shell commands from Python and get the result back and use that input and output. But you also have the ability to build more interesting, more complex data structures inside of the Python script that make it a little bit easier to work with. And I think it's a little bit of a saner syntax, and learning Python never hurt anybody. Right? You can do so much with Python in addition to the shell scripting that if you take the time to do so and then you write your scripts in Python, you'll be able to kind of go anywhere with it. Hey GoPro, did we do those loops already? I like iterator loops, like for I in 110 do echo I done. Yes, we did do those. Here they are. Oh, you mean the sequences, like A to Z? Yeah. No, we didn't do those sequence completions, but those are cool. So GoPro's talking about like, yeah, this is really handy as an expansion. But yeah, so if you take the time to learn a scripting language like Python, you can do what you're doing in Bash, but I feel like it's a little bit more portable. You can even write a script that has conditionals for what kind of operating system it's running on, so you can execute different code if it's on Windows versus Mac OS versus Linux, and even different Linux distributions. You can do that in Bash too, but it's a little bit trickier. And then here's the hottest part of the hot take. Ruby, which has totally fallen out of favor, is actually better for shell scripting than Python. The Ruby OS library has such a clean and clear syntax for working in the shell that it's just beautiful. And it even has this cool capability that if you write a shell command in backticks, it'll just run it. There's a certain point where I look at a script and decide it's going to be a Go binary instead. So true story, GoPro, when I was doing the challenge VM for this course, there came a point where I was trying to do everything in Bash and a little bit in Python to get everything working the way that I wanted to. And it just like, it wasn't working. And I needed things to have the set UID right and not readable. So I needed a compiled binary. And so I wrote it in Rust for that reason. So yeah, it happens. But if there are any brave souls who try to write a shell script in Ruby, you try it and tell me how much you like it, because I think you will. And I think you'll be surprised by how competent the Ruby programming language is for doing your shell scripting. I'm like the only person left that likes Ruby. Ugh, chef. Okay, so we talked a little bit about quotes. We did single versus double. We did variable expansion. We didn't do expressions in quotes though, so let's try that one out. So let's I'm also going to take this time to talk about a really, really cool trick called the here doc. And that's the here doc is how we refer to this. This is kind of a cool trick. So you may come across a situation in which you need to send multiple lines of a file into a file, but it's not the easiest thing in the world to figure out how to do that. With the here doc syntax, you're able to define an entire multi-line document on the command line that a command can use as its output or input. And that's a little bit funny to say out loud. It makes more sense by example, I think. So let's say I wanted to put a list of names separated by lines into a text file. To do that, obviously I could do like echo name one. I'll come up with real names in a second, and do, you know, names.txt, and then I could do name two and append it with the double output redirection, right? Next.txt, names.txt, and that works fine. But that's really, really cumbersome. So something that you can do, and you can script this, especially, this is really handy, especially if you want to generate a config file or something like that, is use the here doc syntax. Here's what this looks like. So to do this, we're going to try cat to names.txt, but then what? We forgot to cat a thing. What are we catting? We're going to use double brackets backwards, and then we'll use EOF, but it can be whatever you want. This tells the shell, hey, you're going to accept input for the next however many lines until you see this pattern. And that's going to be your input for this. So watch, when I press enter here, no command executes. I just get a next line to start working it. So here, let's write some names. Jean-Luc, Will, yeah, that'll work. And then for my final line, I put EOF. Now, if we cat names.txt, they're in there. So what happened was, cat actually took this input from the here doc syntax, and as soon as it saw the EOF pattern, it stopped reading. Yeah, and to as GoPro is saying, EOF is end of file. But as GoPro was saying, this pattern can be anything. Let's do right? So whatever I make the ender pattern be, right, it'll read until it sees that, stop, and then take that as the input for the command that I've declared. So you can see how this would be really, really powerful in a script if I'm generating something like a vimrc or a config file, right, with input parameters, where I want a multi-line file getting generated from my script, but I don't want to have to do it line by line by line. Yeah, the here doc is wild. All right, let's get back into our hw.sh, because the other thing we wanted to talk a little bit about was quotes. So now that we have those names inside the file, this is something that you'll often see be a problem, right? If I have a file full of things that I want to do something with, how do I get those into a variable? And so I say names equals, and then what do I do? So let's try it this way, right? Which is cat names.txt. And then for n in names, do echo n. Done. Okay. So notice our syntax here. Equal sign, no space, dollar sign, parentheses, and then our loop. That works fine, right? Now things can get a little bit trickier if there are quotes inside of the text file. And for that reason, in modern Bash, I prefer to do this a different way. There's another syntax that works for this, and I prefer it. Your mileage may vary, but I prefer backticks. Oh wait, backticks are older? I thought they were newer. That's interesting to know. I really thought that was a newer thing. But that also works just fine. Interesting. Yeah, the reason that I prefer the backticks is because of my experience with Ruby, where in a Ruby script, do I have Ruby? No, I don't. Okay. You can just do a backticked shell command and it'll just work. I find this to be a little bit easier to work with, especially on the command line. And I can't really understand why there would be a reason against it. But if you are playing by the rules, we can do it this way. Or let's say we had a single line thing, or we wanted to combine things, right? So we know that we have, for example, Stack Overflow, the $sign parentheses is POSIX and supported by all modern-born shells, and not so modern with Solaris. Oh, okay. Oh, I got you. It's bash specific is the issue. The backticks that way are bash specific. They're not POSIX compliant. Okay, that's good to know. So if you don't know what shell you're going to be executing your shell script in, you would want to do it with the $sign parentheses for the command expansion this way. But if you had a reasonable assurance that you were doing this in bash, you could do it with the backticks. Cool. But let's say, so we have, right, we have this file hostname, and let's say we wanted to write a script that used the hostname in something. I'm gonna copy all this, or comment all this out. And let's say I wanted to say echo my name is, and then if I tried to do this cat hostname, I'm pretty sure that's gonna not work. Yeah. Oh wait, but that was because oh, that works fine. Just kidding. Hostname is a command, so we can use that just fine. So you can use this inside of quotes. What can be confusing is the way that parameter expansion works. So very often you'll see links like this with curly braces instead. But that's a parameter, which would be something like this. Dang. Pay it forward. So Orbital, thank you so much for gifting GoPro a sub. And then GoPro, good lord, paying it forward. Thank you very much. So let's try this. So we're going to do HN, and we're going to use that command expansion here with parentheses. And we're going to try parameter expansion with the curly braces. Yeah, still no. But if we did it this... Oh, wait. Hold on a second. That was silly of me. Let's try it this way. Yeah, that works fine. So there are multiple ways to do this substitution in Bash, and that can get a little bit funny. And that's why we're gonna link you all to the kind of the Bash Bible at the very end of this. And I would just want to call out, like, obviously some of this is still hard for me to keep in my head, even though I'm trying to give this as an example. Bash is weird, man. It just is. And there's so many layers of it that have been added over the years, and it's a little messy, but it's powerful enough that it's worth learning, especially to automate stuff that you want to do with your Linux system. So despite its idiosyncrasies, I still think that it's worthwhile. But also try to use Python where you can. As much as I think the Ruby shell scripting is cool, you really probably shouldn't, just because it's so... You know, Ruby had this moment, right? And then it's just gone. Unless you're a Rails developer. Alright. So we talked about quotes and variable and parameter expansion. And... Okay, so let's do something real. Let's do something for real. Let's get out of example land. The first thing we're going to try to do is API stuff. I love doing API stuff with the command line and with Bash in particular, just because it's fun to do. To make this happen, we're going to use my favorite API to demo stuff with, which is Swappy. Swappy, the Star Wars API. So, Swappy.dev, the Star Wars API, is essentially just a free API full of Star Wars stuff. It's really not that complicated. But it gives you back JSON results, which are great for learning how APIs, RESTful APIs in particular, work. So we're going to use Swappy to play around a little bit with this. Now, we'll start with the documentation, like any good API, and we'll learn how to do some searching, because that's my idea. My idea is we're going to get some names of ships in Star Wars, and we're going to search for the data for them. So to search Swappy, you do https://swappy.dev/API/ whatever kind of resource it is. In this case, we're going to do starships. And then search, and then the search parameter. So to make this happen, we're going to start with a list of ships. And chat, I need your help. Call out your favorite Star Wars ship. I have a suspicion that people in this chat have one. I've got more than enough if we need it, but I would like to hear your suggestions. Death Star. I wonder if the Death Star Enterprise. Good troll, Orbital. Good troll. The airborne stormtrooper. Death Star is interesting because, well, we'll see why. So Death Star, airborne stormtrooper. I think that's personnel ABC1. For real? X-Wing. The Incom T-65, also known as the X-Wing. I always have a soft spot for the B-Wing. underrated. I guess not a lot of folks here played X-Wing or TIE Fighter. That was a big deal for me as a kid. Let's see. Let's try something a little bit more obscure. Try the TIE Defender. I don't know if any of you would remember the TIE Defender. Yeah, look at that thing. It was like the Empire decided to actually build something that would allow their pilots to survive. Okay, so we've got a list of ships. It's not particularly expansive, but it'll do for now. And we also have some complications in here, which I'm looking forward to. So we'll save this out, and then in a new tab, we're gonna edit swappy.sh. And let's start with our shebang, bin bash. And we're going to start with ships equals, and this is where you can either use the backticks or your expansion here with cat ships.txt. Or what would be more appropriate is to kind of alias the ships variable to a command line option that we send in. So we give it the text file to work with. Okay. You say ships file or ships underscore file would be close to how I do this. In proper bash convention, this would be all caps actually. Ships file is how we would do that. And then the ships equals at ships file. Like so. And what that does is gives us the line broken stuff. Now, let's try this right from here. So for S in ships, do, and we're gonna echo S. Done. Okay, there's our ships.sh or swappy.sh. We have to chmod it to make it executable. Any predictions about output? Do we have any predictions about what we're going to see? All right. Well, hopefully you have your predictions. Let's try it. I'll be honest, that wasn't one of my predictions. Oh, stupid. Gotta give it a ships.txt. Let's try it that way. Okay, there we go. So again, remember, spaces are weird, right? It's a problem. Because now my list of ships is Death Star and then X-Wing, B-Wing, TIE, Defender. I have a problem, right? If I want this to work, and actually if I want it to be URL encoded anyway, this isn't going to work out for me. So I have to do something in order to separate this out. Now, a couple of ways that I could make this happen, right? I could put these in quotes. Right? If I substitute every space with a plus sign, that works. Or let's try it with quotes, right? %s beginning or end of the line with a quote. What? There we go. Let's see what that does. See, the spaces still mess it up. So, and since we have to URL encode it anyway, I'm going to replace the spaces with pluses. And so yeah, I just wanted to call that out, that if you have spaces in your text file, you're going to maybe have some unexpected output when you're doing this in shell scripting. Yet another reason why Python might be an option, because you can kind of get around that. You can get around it in Bash a little bit easier, but since we have to URL encode this anyway, we're going to put a plus in here. And now it's printing out the way we expect, right? Line for line for line. All right, so that's our beginning. And then now we're going to, we're not just echoing, right? We need to do something with it. So we're going to start with the URL base. And what is our URL base? Well, if we remember our Swappy documentation, it looks something like this. And we're not actually searching for people in this case, we're searching for starships. And then we have to fill in whatever we're searching for after that. Right? So then we're going to use the curl command, which accesses URLs from the command line. We're going to curl URL base, and then how do I want to do this? Yeah, there we go. URL base, and then S. Yes, I know there's no space between them. Things. Now that's messy, because the JSON doesn't have any line breaks or whatever, but we're getting the data back. So what I might do is redirect that to so now I'm able to save it. It's ugly, but I have it. But now, what if I wanted to get something specific out of this data? You can see that there's a lot of data in here, but it's, you know, it's JSON formatted, so it might not be the easiest thing in the world to work with. There is a tool that I use on the command line constantly in my day job. Yep, that's right, GoPro, JQ. That will clean this up for us marvelously. So if I wanted to do that, right? Rather than kind of saving these all in one text file, what I could do is I could filter this with JQ first. And if we just think of about a specific, let's just go get the name. Also notice that every one of these has a results parameter, right? You can see that there's a count and then there's a results. So what we're going to do is we're going to modify our swappy.sh. So we're going to curl this. And then we're going to JQ. And the way that the JQ syntax works, it takes a minute to get used to. Let me put this in chat for anybody who's interested. The way that the JQ syntax works is, you think about the base of the JavaScript object, which is the root here over here, and they say, what do we want? We want results and we'll say results.name because we want the name of it. And notice that we're piping the result of this, right, to JQ. Now, I have JQ installed already, and if you're using the challenge VM, you have it too. So now you see that it's filtering right down to the name. And if there had been more than one result, it would have given us multiple. So if I, just to prove that point, actually, I want to edit ships.txt. So let me get rid of X-Wing, B-Wing. Let's just look for wing. See that? It gave us all of them from one result because we were extracting all of the results. Yeah, curl -s does hide the progress. So again, yep, want them back in a list, put them back in brackets. That's a really good good tip as well. We can also do raw. Yeah. If we want it raw, then we won't get the quotes. So if we want to really Unixify this thing, now we just get raw text back, no quotes. Yeah, JQ is crazy. Really, really powerful, especially when you're working with APIs. So let's take a look at this script for a second. So what have we done? We have created a variable. We're using a command line parameter that we're passing in. We're using command expansion here. We are using a variable here with quotes, and then we are using expansion again inside these double quotes to combine the ship name or the search parameter that we're using with the URL base. And then we are using command output piping to send that to JQ. And if we wanted to, of course, we could pipe all of this. I like doing this way, that by default it goes to standard out, right? And then with this, if I want to, I can say send this to ship results.txt, or if I want to see it happen and then also capture it, I can use T and then ship results.txt. Right? So I can see it happen and also capture it. That's the beauty of T. Right. just a couple more things that I wanted to cover tonight. I thought that were valuable. Always tea or Linpeas. Man, Linpeas. Is Linpeas still illegal on the OSCP, or did they reverse that decision? I think they reversed that decision, right? Or no, did they? There was like one guy that took it, and it was like he took it right as they criminalized Linpeas. Oh no, that's right. That's for what it was. They fixed the bug that made it an autopwn. Thank you. Thank you. Thank you. Right, so you can use Linpeas on the OSCP. In what universe is the Death Star a starship? We all know it's a space station. I mean, it has a hyperdrive. Curl verbosity isn't sent to standard out. That is true. All right. The last thing I want to talk about is something that you'll actually want to script or do very often, which is scheduling your stuff. So very often you'll have something that you want to run from time to time, and you give it a script to do that. How do you do that? Okay, well, you write the script and you point something to it. In this case, what you would point to it is so technically you're supposed to do it with these days systemd timers, but they suck. I hate doing it with systemd timers, and cron is still supported, so we're going to do it with cron. To show you what I mean, this is from the ArchWiki, but this is what a systemd timer looks like. And systemd is the init system on most modern Linux distributions. It's what handles the startup process and manages your services, things like that. That's what systemd does. And it works through a bunch of different files, just like everything else on Linux. This is what a systemd timer looks like. I just learned tail-f dev null. Oh yeah, that's a good one for logging, or like for GoPro. That's for like container persistence. Yeah, that's a great one. As a matter of fact, I think the Splunk universal forwarder container has that as the way that its entry point, just to make that happen. Yeah, so this is what a systemd timer looks like, and they're a little bit weird. And you need a matching service file. It just, I don't know, it's a lot. And so in order to not do this, we're going to use cron. Cron is, it's old as dirt, but it still works great. What does cron do? So cron allows you to schedule jobs either as the root of the machine or as an individual user. And you can see what the root cron jobs are by catting etc cron tab, and it'll tell you, especially on an Ubuntu machine, it'll tell you what you have. It also gives you some syntax help with this. It also tells you the path that it uses to determine what the script is, or where the scripts are. But these are the things that it runs by default. And you'll notice that it has these subfolders, etc cron.daily, cron.weekly, and cron.monthly. There are folders that you can just throw scripts in, and they'll run on those cadences automatically because they're already set up in etc cron tab. But you can also just write your own. So to do, let's talk about how that would work. The date command is a really great one to test this. So I'm going to make a dir called sked, just so I can keep this clean, right? And then I'm going to vim sked.sh bin bash, and then I'm going to say echo date to home taggart sked sked.txt. Okay, now I'll touch sked.txt, but it doesn't have to exist in order for this to work. I do have to chmod the shell script. Wow. Okay. And once I have that done, I have a command called crontab. Now, crontab-e will allow me to edit my cron jobs as my own user, right? This isn't sudo crontab, which would be for the root. This is just for me. And this is actually one of the best reasons to learn Vim, because then you can use it to do this. Bin nano is easiest. Okay, but we now know how to use Vim, so we're going to use Vim. And this is our cron tab. This is our table of cron jobs. Now, right now, there isn't anything, but we're going to make one. And the syntax for this can be a little bit confusing, which is why we have good old crontab.guru, where you can build out your cron syntax. And in our case, we're just going to do every minute, so it's easy. But if we wanted to do like every, what is it? */5? Yeah, every 5th minute. It's every 5 minutes. You could do that if you wanted to run every 5 minutes or 10 minutes or whatever. But this is every minute. And that's what we're going to do, right? Every minute of every hour of every day of every month of every day of the week. So easy enough. So what are we doing? 2, 3, 4, 5. And then the command is we're going to do an absolute path to it. In this case, home, empty taggart, sked. Can't spell, unfortunately. Sked.sh. There's nothing in sked.txt now, but if we give it a minute, if everything's gone according to plan, I should start seeing timestamps show up. A watched cron job never executes. Hey, jobs, yeah, run it. Yep, works just fine. So that'll continue to do its thing every minute, right? And I'll get more and more timestamps in there. That's how we do cron jobs. Now, that's kind of a goofy thing to do, right? What will we actually do on a schedule? Well, we might do something like back something up. So to do that, I'm going to write a backup script. Have we talked about the watch command? We have not talked about the watch command. That's a good one if you're live, if you're on the system. So if you want to do like a periodic ping or something like that, that's really, really handy. Good call out, Neon. So one thing that we're probably going to want to do is back something up someplace. That's a possibility. And so to do that, we're going to do, you can do it with tar, of course, if it's local. To tar would compress a file or a folder and send it someplace. But the tool that I want to teach in this particular context is rsync, because it is so crazy powerful. And I'm going to send you all, this is the cheat sheet that I like for rsync. Now let's take a look at it. So what rsync allows us to do is sync to two locations. And what is cool about it is that it's not just an overwrite. It does a differential analysis. And so it can make backups really, really easy to do. As a matter of fact, most of the kind of GUI built out backup solutions for Linux have rsync running in the background. That's really what it is. But rsync exists on macOS too, so be aware of that. And this is the other thing that makes rsync crazy powerful, is the ability to run over SSH. So you can do trying to find, it's like -E, right? I don't know why they don't have it in here. But yeah, rsync-E allows you to set up an SSH backup. And so if you wanted to do that, really, really cool. I'm even going to tell you about a service that I have used professionally in the past. Pricing's pretty reasonable, called rsync.net. If you get good with this and you want to think about using rsync for your backup solution, rsync.net has really, really powerful backups that you can, it'll just give you basically block storage, and its whole deal is that you'll rsync to it. That's it, right? That's all it lets you do, but it works great. And the pricing isn't terrible, right? So up to basically a terabyte, it's 2.5 cents per gigabyte per month. So if you have a lot of storage that you need to back up and you're looking for pretty reasonable pricing, you might want to check out rsync.net. Okay, so let's play with rsync a little bit. What we're going to do is we're basically just going to do this rsync-avz.source.destination. And you can write this command right into the cron job. You don't have to write it as a script, but you can write it as a script, right? So you could say, you could write a log someplace if you wanted to. All the cron logs itself. Right. So if we do this one, rsync-avz and source and destination. So let's try that out just as a one-timer. We're going to do sked to /opt. Right? Yeah. Let's do it to temp, just for now. There it is. Right? We send that stuff there. Now, if I did it with the folder, you'll notice that the folder's in there this time. right? Although it just creates essentially a copy of the folder there. So if we wanted to if we wanted to schedule that out, right, we could go cron tab-e and maybe set that up every minute and every, say, 2 hours, right, every day. And we do dang, where is so if I wanted to do it right here, I could run the rsync command here, but I could also do, say, home empty taggart / backup.sh, right? And then I gotta go write backup.sh. And here I would say rsync avz home taggart / sked the temp, or wherever my other backup destination is. And eventually that should work out. So, oh wait, what did I forget to do? Chommed. Again, that should work out, but yeah, backup works. So that is how we would schedule a backup. And rsync is a kind of a deeper topic, but rsync is how we would get started with that, creating our backups and scheduling the task. How well does it handle version control compared to Git? It doesn't handle version control. It just handles diffing, basically. So it's like kind of plain text file diffing, really. So not super well, but it for most purposes it actually works great. I don't believe it does file hashing though. I could be wrong about that. Let's see if... Yeah, by sending only the difference between the source files and the existing files. Yeah, it doesn't really tell us here how it's doing the diffing, but I'm pretty sure it's essentially the diff command is how it's doing it. Line by line. So if it's a binary blob or something like that, it won't really know how to deal with that. It'll just use the different dates of change. All right. We're coming to the end here for session 4. But just to close out, a couple of pro tips. And actually, I'm glad, Born Again Shell, that you brought this up. So when you're writing scripts, save your stuff and save them in a single place, in a scripts folder or something like that if you're working on a single system. But also back them up, because you're gonna come up with something awesome and you don't want to have to lose it and have to rebuild it. So I recommend using Git. Create a Git repository of your shell scripts so that you can download them onto whatever new server you're working with and just have them ready and available for yourself. And as a matter of fact, you can set up your user profile so that your script folder is in your shell's path so that you have access to that. Another really important point is to make your scripts idempotent. And that's a big word and I love using it, but what does it mean? Idempotence is it's a mathematical property But what we really mean is that you want to make your scripts only change things once, so that if I were to run a script twice, it wouldn't double down on whatever change it was making, or, you know, kind of overwrite the work it had already done. You don't want that to happen. So inside your scripts, you want to have some sort of safety check that, you know, or sanity check, that whatever it's supposed to do hasn't already taken place. Or that if it does do something, it doesn't do any sort of damage by creating duplicates or whatever. Idempotent. And more generally, you want to safety check everything. When you start writing shell scripts to automate stuff, you are going to be quick and dirty. And sometimes that's fine. But the more complicated you get, and the more into the weeds and into the, you know, deep nested nuts and bolts of your OS that you get with your scripts, the more opportunity you have to get something wrong. And so you want to do safety and sanity checks inside your script to make sure that it's only making changes how and when you want. And then lastly, in the shell scripts, as we've seen, text is cool right up until it's not. And then all of a sudden, you're going to need something more structured. And for that reason, I'm going to again ask you to consider that as fun as bash scripting is, and as useful as it is for many, many cases, that if you are on this path of learning how to use these systems, or if you're on the InfoSec path and you're trying to become an analyst or something like that, please, 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 please consider adding a scripting programming language like Python to your repertoire. It will absolutely explode your capabilities in whatever technical skill set you find yourself. You will find new ways of doing things because you have the power of programming at your disposal. I strongly recommend it. There are lots of great resources for learning Python. Last year's Hack Summer was about learning Python, so if you go back on YouTube and check those out, you can get started with that as well. But I think that's going to do it for shell scripting on Linux. So lastly, this is the Bible. The Advanced Bash Scripting Guide. It looks as hardcore as it is. Any chance you can start streaming earlier next time? It's almost 4 a.m. here. Sorry, Born Again Shell, but no. This is about as early as I can do it. This is 5 p.m. I just finished work, and then I get going streaming here. I'm really sorry about that. Obviously they're recorded, but this is about as early as I can start. But yeah, so the TLDP Bible is, I think, the most comprehensive set of instructions on how to use Bash. And if you want to know the ins and outs of this language, this is where you got to go. All right, so that's going to do it, friends, until next time. And our next session for Hack Summer is the final session for Hack Summer 21. I'm really excited for this one, not just because it's the closeout session, and if we have time, we'll do the speed run of all the challenges that we did in the VM. But we're also going to talk about one of my favorite topics, which is containers. We're going to talk about LXC and, of course, Docker, and learn how we can use containers to take our Linux OS to the next level and make things a little bit more easy and more streamlined to deploy really, really cool software right from the command line. So that's the plan for next time. Let's see if there's anybody else streaming right now that we can send you to. I don't have anybody on my list, so I'm going to send you on your merry way. But until next time, friends, so thanks everybody for hanging out. Thank you, of course, GoPro and Orbital for the subs gifted in the chat. Really, really appreciate it. So until next time, friends, be good to yourselves, be good to each other, and I will see you next time.